And in that case also we have seen that the eccentric loading is of two different types. And in that case we have calculated the dimensions of that bolt by considering the different types of loading. Now, as we are going to see, next part is the welded joints. Now, basically, welded joints are preferable than the riveted joints. Nowadays, these welded joints are used, uh, and they have many more advantages over the riveted joints. But if you are going to see the basic from which the welded joints have started, is nothing but blacksmithy. In case of blacksmithy, if you are going to see, uh, the two parts are joined together by means of pressure and by increasing the temperature of that metal. Okay, so from that, the this type of uh, joining metal or method by means of which we can join two metals, that has improved. And later on, by means of the fusion, that is by melting the one metal, and we can make the bond in two different metals. That technology has developed, and nowadays the welding technology that has been improved much more, and widely this technique has used for joining of two different parts together and forming a required component. Okay, so this type of technique has improved. Now in this case, if you are going to see, then this is alternative method for the casting or forging, and as replacement for the bolted as well as riveted joints. Now, if you are going to see advantages, then the advantages of this welded joint, first of all, the welded structures are usually lighter than the riveted structures. Basically, we have all done these advantages over the riveted joints. So we are going to compare bolted joints as well as riveted joints also, because in this case, if you are going to see, then the riveted joints are replaced by means of this welding or welded joints. Okay. So in this case, what we are going to see is the advantages over the riveted joints. So they are relatively lighter. Okay. This is due to the reason that the welding uh, uh, in case of this welding, this gossets or other type of connecting components are not used. Okay, for that we have to see actually riveted joints. Riveted joints has to be seen first. But as it is last, we are going to see only introductory part of riveted joints. That's why we'll see later on what the riveted joints are. Then second, the welded joints provides maximum efficiency, maybe up to 100%, which is not possible in case of riveted joints. As far as the efficiency you are going to consider, efficiency is considered for the leak-proof joints. And as you know that this welding process is used for the pressure vessel also. And if you are going to see the old pressure vessels, they were manufactured from the riveted joints. And as we are going to compare the leak proof efficiency, then these welded joints are going to provide us maximum efficiency up to 100%. That is not possible anyhow in case of this riveted joints. Okay. Then uh, alteration and additions can be easily made in the existing structure with the help of these welded joints. As the welded structure is smooth in appearance, therefore it looks okay good also. That is aesthetic view is good for the welded joints. In welded connections, the tension member are not weakened as in case of riveted joints. Riveted joints, members are weakened because of the drilling of hole, because riveted joints are created by means of drilling hole, as well as bolted joints are also created by means of drilling holes in the parent material, and hence they become weak. That's why what we can see is the in case of welded joints, the strength has added into that. They are not weak as we are going to see in case of these riveted joints as well as in bolted joints. Okay, a welded joints has great strength definitely. Upon welded joints has the strength of the parent material itself. That means we are not going to drill any hole in the parent materials. That's why strength will be improved. You can say it is not reduced. Okay. Then seventh advantage is that sometimes the members are of such a shape, that is complicated shapes, that they offered difficulty for riveting. That means in case of that complicated shapes, it is not possible to adapt the riveting process. But that can be done easily with the help of welded joints, because you know that welded joint is nothing but you are going to create the fusion in material and are connected with each other. It doesn't have any concern with the shape of that parent materials. Okay. Then the welding provides very rigid joints, and this is in line with the modern trends of the providing rigid frames. So, in case of riveted joints, that rigid frames were created, and nowadays, as we are going to see, the trend is there that we can reduce the material where it is not required, and we can add the material where that structure becomes weak. So that type of trend can be followed with the help of this welded joint. Then the process of welding takes less time than the riveting, even than the bolted joints also. So time will get consumed in case of riveted and bolted joints, which we can reduce in case of this welding joints. Though these are some advantages, you can add two more, four more in that advantages, and you can write the advantages of these welded joints. Now, if you are going to see the disadvantages, then in case of these welded joints, there are some disadvantages also, and that disadvantages are listed as followed. Oh. So, first disadvantage is that since there is an uneven heating and cooling during the fabrication is nothing but another word which we can use for the welding process. Okay. Therefore, the members may get destroyed. That is, shape may get destroyed, or additional stress may get be developed. Additional stress, that is nothing but by means of uneven cooling. Because of the uneven cooling, that thermal stresses may get induced in that parent materials, because we are going to heat that parent material, and later on they are allowed to cool. And if the process by means of which we are allowing to cool that parent materials, if that is not followed, then uneven stresses may get induced in that parent material. It requires highly skilled labor and supervision also. That is, it is laborious job, and skilled labors are required for this. Now, next is, since no provision is kept for the expansion and contraction, because we are going to make cut to cut joints in the frame. Therefore, there is a possibility of crack development in it. That is, when we are going to create the welded joints, at that time we are not providing any type of allowance in that. They are cut face to face. That's why if we are not going to provide allowance, then there may be possibility, because of the uneven heating. Okay, there may be possibility of creating cracks. Okay. Then last, that is fourth. It is not last. You can add one more into that also. The inspection of welding work is more difficult than the riveting work, and it requires NDT testing. That is, non-destructive testing methods are used for the inspection of the welded joints. Okay. So these are some advantages and disadvantages of the welded joints. You can add one more in that, and if it is asked for the exam, you can write it. Next thing is that we are going to see types of welding. But before going to see the types of welding, basically what the welding is, there are two types of methods are used for the welding. Okay, out of that, one is process used only heat. Okay, that is the parts are heated. That is, it is called as fusion welding. Okay, and in second type, heat plus pressure is used, and in that case, the uh, forge welding, it is called as forge welding. And in that case, the parents materials are heated and they are pressurized so that the connection between that two parts will be done. So fusion welding and forge welding, these are the basic two types. But as far as our syllabus is concerned, or what we are going to see, or what we are going to call as a welding, that we are going to see as a fusion welding only. The second part, that is the forging or forge welding, that we are not going to see. Okay, so we are going to concentrate on the fusion welding. Then these fusion weldings are having different type of joints. Out of that, we are going to see first type of joint is the lap joint. Lap is nothing but we are going to mount one over another. If the one over another part is mounted, that is called as lap. Okay, so that connecting of that two parts by means of lapping them on each other, that is called as lap joint. Okay, and other type of joint, that is called as butt joint. Now butt, that is nothing but they are just connected with each other, they are not lapped, they are not kept on each other. Okay, so that is called as butt joint. If you are going to see the lap joint, then there are different types of lap joint. Okay, first is we are going to call it as a single transverse, that is only one line is made for the welding, that is called as single transverse lap joint. Whereas from the both side, if you are going to make welding connection, then it is called as double transverse type of lap joint. If we are going to make the welding in such a way that at the lateral part of that parts, then we are going to call it as a parallel fillet joint. Okay, and one can be combination of this, that is transverse as well as parallel can be combined together. That can be made as a next type of lap joint. Okay, and they will be more strong than this single transverse, double transverse, or parallel fillet type of joints. Now these are the three basic types of the lap joints. Now next, this is the butt joint, where two parts which are required to be connected together are kept together, and later on the run of welding is made. Okay, material is filled into that. So first of all, it is called as square butt joint, where square type of material is filled in that uh, the gap between two parts. Okay. Then second, to have the more strength so that we can fill the more material into that, the V shape is made for that two parts which are joining together. That is called as single V butt joint. Then again, to have more strength, we can use U type of butt joints. That is English U later is made, inverted U you can say, and material is filled in between that. Then to have more, if the thickness of plates which are connected with each other is more, then we can go for the double type of V joint. Here also there is no doubt that we can use single V joint, or to improve the strength we can use the double V joint, and likewise that we can use double U joints too. Now apart from all this, we are going to have other types of joints also, butt joints and lap joints. Okay, we have seen their types, but apart from this butt and lap joint, we are going to have these three different types of joint. One is called as corner joint, when plates are kept 90 degree with each other, and if the material is filled between that two plates, then it is called as corner joints, basically for creating the corners of 90 degree or more than that, or less than that also angle, we can use these corner joints. Then edge joint. If the two plates are connected with each other, and at the edge, if you are going to feel that material, welding material, then it is called as edge joint. They are normally created at the edge, and later on, the shape of the plates which are connected with each other, that may get varied. Then next is T joint. In between a long plate, if you are going to connect a vertical plate, then the welding is done at the corner. Okay, that is called as T, because cross section of that type of joint is looking like the inverted T letter of English. So it is called as T joint. Got it? Any question related to this? If not, we can move further. Our next part which we are going to see is we have to calculate the strength of these welded joints, because that is going nothing but what we are going to say as calculating dimensions, and that is what we are going to call it as a design of that joints. Okay, so basic part is to calculate the strength of that joint. Now we'll calculate the strength of these welding joints, that is lap joint and butt joint, step by step, one by one. Okay, so first of all, we'll see the terminology which is used. In this case, this is the first single transverse fillet weld and double transverse fillet weld. Okay, for this, what we are going to see, the L is the length over which the welded or welding is done. Let the P is the force which is applied, okay, which is perpendicular to this welding run. Let the S is the length at which the welding material has filled. Okay, and later on we'll see here S is the thickness also of that plate which is connected together. Now from all this, we'll go in detail and we'll see this diagram. Now this diagram is expanded part of that lap joint. Now here we are going to approximate this curve A to C. Now this is uneven curve. It has been shown as a smooth curve. Okay, this smooth curve may not be achieved every time, but we'll see, or we'll create the approximate straight line and we'll approximate this curve. So A to C we are going to make as a straight line. Now it has become triangle A, B and C. And whatever may be the material which we are going to fill or to connect these two parts together, two plates together. Okay, this plate has a thickness S, and that much material we are going to fill, and that's why we can say the height of this triangle as a S. Okay, and T is the, what we can say, the thickness of throat. Now this throat thickness, that is nothing but the approximately thickness where the material has been filled. Okay, then L is the length that is perpendicular to this slide. Now L is the length of that weld, or weld run we can say. Got it? Now in this case, from triangle ABC, we can calculate T. T is equal to S, this is height, S sine 45, right? So T is equal to 0.707 S. Now this has been calculated from the trigonometry, that is triangle ABC. Okay. Now from this, once you are able to calculate, or once you are able to understand this T and S relation, then we'll calculate the minimum area of the weld. Okay, or throat area. It is called as throat area, minimum area, and that we are going to take as a this area which will be at the throat length and multiplied by the length. So that slice, we can say, that plane which is at the 45 degree here, this plane DB, dB. If you are going to create plane up to the length L, then that plane we are going to consider as a minimum throat area or throat area. Okay. So when we are going to calculate area, that will be equal to throat thickness into length. So already we have calculated this T, throat thickness, multiplied by L, length of that well. And if you want to write it in terms of S, that is the thickness of that plate, then it will be 0.707 S into L. Okay, this will be the throat area. Now, as we know that the stress is equal to force divided by area. So force we have considered already as a P. So this force is equal to area multiplied by allowable tensile stress. So this that force P, which can be sustained by means of this welding joint, is equal to area, that is throat area, which we have calculated right now here, T into L, or 0.707 S into L, multiplied by allowable tensile stress. Let us consider that allowable tensile stress as a sigma T. Okay. Then the strength of this weld or welded joint can be calculated as P is equal to throat area multiplied by sigma T, that is 0.707 S into L into sigma T. Okay. And if you want to calculate the strength of double joint, okay. Now this we have calculated for the single lap joint. If you want to calculate it for the double lap joint, then from this side also we are going to make a welding here. And we are going to have one more triangle, right? So we have to calculate this strength also. This plane also can be considered in the tension. So it will become exactly double. So the load carrying capacity will become double than this single joint, single lap joint. So for the double lap joint, it will be 2 into 0.707 S into L into sigma T. Okay. So 2, if you are going to multiply with 0.707, it will become 1.414 S into L into sigma T. Okay. Now, this is what we can call as the strength of this lap joint. Now, the strength of lap joint which we have calculated is for the transverse lap joint. If we want to calculate the strength of parallel lap joint, then as you know that we can calculate the strength by means of calculating area, okay, multiplied by the allowable tensile stress. So that is calculated, and later on, if you are going to consider that this weld is undergoing for the shear, then we have to just consider the allowable shear strength, allowable shear stress, and multiply by area to the stress, that will become force, because force is equal to cross-sectional area multiplied by allowable stress. It may be shear or it may be tensile. But when we are going to consider the allowable shear stress, it will become shear strain. If you are going to use the allowable tensile stress, it will become tensile strain. Okay. Now, in this case, we are going to calculate it as from the one side, if P is equal to 0.707 S into L into tau, okay, for the one line that we have calculated. And from the other side also, if you are going to make the joint or make the welding, then it will become 2 or twice of this 0.707 into S into L into tau, that is allowable shear stress. Now one can understand that this welding will undergo to the shear, whereas the previous case, this welding will undergo for the tension. So here we have considered as a shear strength, shear stress, okay, and in previous case we have considered sigma T, that is tensile strength. Now one can combine it together. So in this case also, where we can calculate by means of replacing this L by means of L1 plus L2 plus again L2, that is L1 plus twice of L, okay, L1 plus twice of L2, and total length of this weld is calculated, and that can be put here. This L is equal to, and hence we can calculate the strength, shear strength as well as tensile strength of the welded joints, which again can be considered as a lab joint. Any doubt up till now? If you have any question, you are free to ask. Hello, you can write in comment box also if you have any question. Hello. Yeah, sir. Do you have any doubt?
No, sir.
Okay. Can we move further?
Yes, sir.
Okay. Now we are going to see the special case of fillet weld joint. Now the special case is nothing but as we have calculated the strength of this welded joint in case of tensile as well as shear force. Now here what we can see is this is the special case where one rod is connected with the vertical plate or cylinder is connected with the vertical plate with the plate by means of this welding. Now in this case, what we required is that just to calculate the length of this welded joint. But while we are going to calculate length, this cylinder is undergoing for the torsional type of loading, or it is sharing the torque. So in this case, if you want to calculate the strength of this welded joint, what we are going to do is that we are going to consider this torsional loading also. Now, in this case, let us consider that as previously we have considered T is the throat thickness, S is the width of the welded joint. Okay. In addition to that, we are going to consider D as the diameter of that rod which is connected to the plate, or diameter of that cylinder which is connected to the plate. Okay. Then R is the radius of that cylinder or rod. T is the torque which is acting on that rod, which is trying to what we can say create the torsional stresses in that rod, or is trying to twist that rod. That is the T. Then S is the size of that weld. Okay, and this leg, that is nothing but we have to calculate total length of that weld. Okay, on one side you have just consider this S. Then T is the throat thickness that already we have mentioned. Now we are going to calculate the polar moment of inertia of the welded section. Now this welded section, we are going to calculate the polar moment of inertia of that. And that you know that pi into T, okay, T is the thickness, into D cube divided by 4. That is pi by 4. Actually D cube was there and multiplied by T. That is we have calculated the polar moment of inertia of this triangle. If this triangle is run or is rotated along this cylinder, then whatever may be the area which may get formed, that area, that for that only we have calculated this polar moment of inertia. Otherwise, polar moment of inertia of this cylinder will be pi by 32 d raised to 4. But we have calculated this polar moment of inertia for this only welded section, this black part which we are going to say, and has a thickness equal to T. Okay. For this, when we are going to calculate this polar moment of inertia, it will be pi into D, that is the periphery, multiplied by D into T, that is the area which we are going to consider for the weld. Okay. So pi by 4 D square first we are going to consider the total area, and multiplied by its thickness and diameter. So that polar moment of inertia we have calculated. Now when the stress is considered, okay, shear stress in that material, that tau max is equal to 2T divided by pi into L into D square. Now this shear stress is considered as a 2 into T divided by pi into 0.707 s into d square. This formula has been derived from the basic formula as a t by j is equal to tau by y. Okay, and from this we can calculate the shear strength in such a circular section. This is the special case for that. Okay, now first case we have seen for the torsional type of stresses. If second case, this movement is created in that is nothing but this cylinder get loaded in such a way that it will create the movement. Can you imagine it? That is nothing but we are going to apply load at the end. This type of movement will be created. Okay, and it is created by means of applying load at the end of the cylinder like this. Okay, if the force is applied in this way, vertical force, then the movement is created into that. And to sustain or to calculate this type of loading, what we are going to do is that we are going to consider that bending stress in that movement. And for that, we are going to use equation as m by I is equal to sigma by y. Now this m by I and sigma by y, if you are going to take y to the other side, it is going to become y divided by I, or I to the other side, that is only keeping the m at the place, then it is going to become I by y. And this I by y is nothing but sectional or section modulus. Okay. This section modulus value we are going to calculate for that welded joint. Now, section modulus for different type of welding joints that we'll see in the table which is provided. Okay. Now, in this case, all the terminologies are same. T is the throat thickness, S is the size of that weld, M is the bending moment, D is the diameter of that load. Okay. And Z is the section modulus of only that welded triangle, welded part. Okay. Now, if you are going to consider this bending stress, then sigma B is equal to M by Z. So, Z is the what section modulus, that is I divided by Y. And in that case, we are going to calculate section modulus of only welded joint. Okay. So, it will become M divided by pi T D square divided by 4. So this sigma B will become 4m divided by pi T D square. Okay. Any question? Now here we are going to use same equation which we have derived already, that is T is equal to 0.707 S. And if you are going to replace this T by means of S, it will become 4m divided by pi 0.707 S into D square. If you are going to divide this 4 by means of this 0.707, it will become 5.66 m divided by pi s d square. Any question?
No, sir.
Okay. So we'll move further. This is one more special case for the this lap joint or for the welded joint. And in this case, if the T joint is formed and if this vertical plate is subjected to the torsional loading, okay, if that vertical plate is uh, twisted by means of the force which is applied on that, in that case, how to calculate the strength? So here also we are going to calculate the strength of this welding. We are going to consider from the both side this welding has done and this T joint has been formed. All the terminology we are going to keep constant, that is T is the throat thickness, S is the width of that welding joint, okay, or size of that welding joint. L is the total length of that welding joint from one side. It will become twice when we are going to consider both sides of that welding joint. And we are going to calculate the polar moment of inertia of welding section. Now this polar moment of inertia Z, which we are going to calculate, that will be given by 2 why, because we are going to consider from the both side, T into L cube divided by 12. Now this polar moment of inertia is calculated by means of, again, by considering the section as a triangular section of that weld. Now for this triangular section, T is the height of this triangular section, L is the length. So we are going to calculate this T into L cube divided by 12. Okay. And we are going to multiply it by means of 2 because we are going to consider strength from both sides. So this J polar moment of inertia of this triangle from both sides, that has been calculated as T into L cube divided by 6. Okay. Now this shear strength is calculated as tau is equal to, or shear stress is equal to, torsional force or the torque which is applied multiplied by L by 2, which is applied at, or we are going to take this total strength at the center of this plate. That's why it will be L by 2 divided by the J, and J is T L cube divided by 6, because we know that basic equation that T by J is equal to tau by Y. Okay, so this tau by Y, out of that Y is L by 2, that's why it will become to the other side. So T into this L by 2 divided by J, that is T into L cube divided by 6. If we are going to take this L by 2 and this 1 by 6, then it will become 3. So tau is going to become 3T divided by small t, that is the thickness, where T, capital T is the torque and small t is the thickness, throat thickness. Okay, multiplied by L square. Now if you are going to put this T in terms of S, T is equal to 0.707 S. That's why here we can put value of T as a 0.707 S, and remaining value will remain same. So this final equation of tau is going to become as, just a minute.
मोबाईल कुठे आहे?
Okay, so this is what the final shear stress equation for this T joint, which is subjected to the torsional load. Now, before going to calculating the strength of butt joints, do you have any question related to the strength of these lap joints and special case of that lap joint? If not, we can go further.
No, sir.
Okay. So the strength of butt joint is calculated again by means of calculating the area of that weld multiplied by the force. So If you are going to calculate the force, force divided by area is equal to stress. That basic equation we are going to consider. Okay. Now in this case, for the single V butt joint that we are going to consider, important thing is that how to calculate the area of that butt joint or that welded joint. That is only thing. Now in this case, simply we are going to consider the total length multiplied by thickness. That is the area which is undergoing for the tensile load. So here the force P is applied. So this force P is given by area multiplied by tensile stress. Stress is equal to force divided by area. So force is equal to area multiplied by stress. So simply we can calculate this T into L into sigma T. Okay, that is the strength of this single V butt joint. If you want to calculate it for the double V butt joint, then this butt joint is divided into two parts, two different parts. Out of that first V joint, we are going to consider thickness as a T1, and second V we are going to consider as a T2. So total thickness that we have to calculate T1 plus T2 into L into sigma T. Okay, that will be the strength of double butt joint. Any question? If not, next part is that axially loaded unsymmetrical welded section. Now this unsymmetrical welded section, that is nothing but if we are going to consider the load which is applied is somewhat eccentric. Okay, so unsymmetric sections are there, and in that case the CG of that unsymmetric section is not lying on line where the load is applied. That's why this this type of structures are considered in eccentric loading. And in that case, how to calculate the strain that we are going to see. That we'll see to the not next lecture. We'll finish it right now, and later on we'll see one example in the next lecture, maybe today, if timetable allows us. So in this case, what we are going to calculate the movement of top weld about the gravity axis. Now this is what the gravity axis is. CG is lying. It is lying at a distance A from the upper side and B from the lower side. Okay, of this L section. Now, if you are going to take this movement of this welded joint, then it is LA, that is this LA into F into A. Okay. So likewise, we can calculate the movement of bottom weld joint, that is LB, that is the length of that bottom weld, multiplied by F, that is the thickness, and multiplied by B. B is the distance of that CG from the bottom weld. Okay. Now, if we are going to take the sum of these movements, and if we are going to take the sum of these movements at CG equal to 0, that's why we are going to consider it as a balanced structure. Okay. So we are going to take sum of all these movements at CG equal to 0, and that will become LA into F, that is the movement of upper weld. Okay, LA is the length of that weld into A is the distance of that weld from the CG, minus LB, that is the length of this lower weld, into F into LB, sorry, into B, that is the distance of that lower weld from the CG. So if you are going to take this equation, we can write this LA into A is equal to LB into B, or we can write the L, that is the length of total weld, L is equal to LA plus LB. Then from these two equation number 1 and 2, we can write LA is equal to total length into B, that is the distance of lower weld from the CG, divided by A plus B, that is the total length of plate. Or LB can be calculated as L total length into A divided by A plus B. Okay, this is what the special case of this unsymmetric welding. Okay, any question?
No, sir.
Okay, then today's date is
6th of November.
6th of November 20. So 51, 21, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 17, 20, 22, 26, 21, 22. Vishal Gangthade, unmute yourself. Vishal Gangthade, unmute yourself. If your number is not there, you let me know. Otherwise, you can leave the class. Thank you. Thank you for listening me. Have a nice day. Vishal Gangthade.
Hello,
हाँ,
sir. 54, sir.
54. Your name, roll number is 54.